Hello again, pre-calculus. These are the trigonometric facts you must know to survive pre-calculus. You should have this sheet. I'm basically just going to put it up. I'm not going to go through filling it up. The Pythagorean identities I went over yesterday and in the last video. All I've done is basically written them a slightly different way, subtract cosine squared from both sides or subtract sine squared from both sides. And then I've used them to rewrite an expression in a simpler form. So make sure you've got all of these. These particularly come up over and over again, and you need to be able to look at them and say, oh, hey, I recognize that. That's cosine squared. These, they don't occur quite as often. So what you need to be able to do in things for these is say, hey, that looks like it might be an identity. Why don't I go check? So basically, anytime you've got two things, and either they're both squared or one is squared and one is 1, you should at least check whether it's an identity. It might not be, but sometimes it is. And then again, simplify the example. Again, simplify the example. So make sure you've got these. You also will need to know the first quadrant of the unit circle. You're going to need to know it in degrees and radians. You're going to need to know your cosine and sine. You're going to need to know your tangent. This is old stuff. We've got to get it in your head. You also need to know, since the other three quadrants are just reflections of this, if you've got the first one solid and you know what's positive or negative in each quadrant, you'll be okay for all of it. You need to know how to simplify radicals. The other thing it's going to be important to know is difference of squares. When you have a binomial by a binomial, and they have exactly the same numbers, but once it's a plus and once it's a minus, you get this. Now that is useful in two ways. One, if you see something like, I don't know, sine squared minus, okay, I actually have no idea, cosine squared, you could factor that into sine theta plus cosine theta times sine theta minus cosine theta. I don't know why that would be useful, but you could do it if you wanted. But when it really comes in handy is in a case like this. If you got 1 plus sine theta, and you need to simplify it somehow, if you can multiply by 1 minus sine theta, that becomes 1 squared minus sine squared theta, which is cosine squared theta. So that's handy really, really often. All right, we are going to use all of these things to verify trigonometric identities. Verifying means proving that they're true. Since we are proving that they're true and not using the fact they're true to do something else, you cannot cross the equal sign. You can't do the usual, when you're solving equations, you can do anything to one side so long as you do it to the other side as well. You can't do that here. You can only change one side. You can't ever go across the equal sign. Best to start with more complicated side. Use the identities when possible. You can factor, you can multiply, express all trigonometric functions in terms of sine and cosine. That's the thing I do most often. And it's important to note, don't cross the equation for the equal sign. All right, I'm going to do all of them. I didn't get to all of them in class, but I'm going to get to all of them now, so this is going to be a long video. Bear with me. 1 plus tangent squared. Normally the first thing I do is go to sine and cosine, but in this case I see an identity right in front of me. I'm going to take advantage of it. Secant squared of x. 1 plus tangent squared equals secant squared, so I'm simply going to replace it. Now I've got secant squared over secant. What I can do is cancel one of the top secants with the bottom secant. This becomes secant x over cosecant x. Now I'm going to go to expressing in terms of sine and cosine. That's 1 over cosine x over 1 over sine x. I'm not crossing the equal sign, I'm just using more space is all. Really important, we will use this a lot. Dividing by a fraction is the same as multiplying by its reciprocal. So I rewrite this as 1 over cosine x times sine x over 1. This is sine of x over cosine of x, and that is equal to tangent of x. So we have proven that the two sides are equal. Next problem. This is the more complicated side. I'm going to start by rewriting in terms of sine and cosine. Cosine stays. On the bottom I've got sine. Cotangent squared is cosine squared over sine squared. I'm going to simplify this a little by doing the multiplying by reciprocal thing. So the bottom is going to flip over and it'll be sine squared over sine theta cosine squared theta. Now, this cosine can cross off with one of these, and this sine can cancel out with one of these. And what I'm left with is sine theta on top and cosine theta on the bottom, and sine over cosine is tangent. That was our goal, so we have proven it. C is very simple. I urge you to try it yourself, but here's how it would work. Cotangent is cosine over sine. Cosecant is 1 over sine. Dividing by a fraction is the same as multiplying by the reciprocal. Sine cancels out, and you're left with only cosine of x over 1, or just cosine. That's it. This one, a little more interesting. So, you know what? Let's start with this side. We could do either one. It's not clear which one is more complicated. I'm going to start with this one. So 1 over. I'm going to rewrite this as sine over cosine. And this is 1 over cosine. Okay, well, these have the same denominator, so I can actually combine that a little. 1 over sine of x plus 1 over cosine. Well, all right, that's division by fraction, so that's multiplying by the reciprocal. And now I've got 1 times, well, 1 times doesn't really do anything, cosine of x over sine of x plus 1. That's what we wanted, so we're done. You don't always get there in so few steps, and when you're new at this, you're going to try some ways that don't get you to where you want it to go. But you need to be persistent and just go back and try another way. Okay, this is a little weird. Cosecant theta minus cotangent theta. Okay, well, the one with a fraction looks more complicated. What I'm going to do, I'm going to use the difference of squares. These aren't squared, so I can't use any of the identities. But I can multiply by anything, so that as long as I do it on the top and on the bottom. So I'm going to multiply by cosecant theta minus cotangent theta over cosecant theta minus cotangent theta. Since it's the same on the top and bottom, I'm multiplying by 1, which means I'm not changing any values, just rewriting it in another form. So the top becomes cosecant theta minus cotangent theta times 1, which doesn't do anything. But this becomes cosecant squared theta minus cotangent theta cosecant theta plus cosecant theta cotangent theta, those cancel out, minus cotangent squared theta. Hey, look, there's squared terms in there. That looks like an identity. So you go back to your things you need to remember. Well, look at that. Cosecant squared minus cotangent squared is equal to 1. So I can replace that. I get cosecant theta minus cotangent theta over 1, which is the same thing as cosecant theta minus cotangent theta. We're done. Last one on this page. So, this looks a little more complicated, although it's hard to say for sure. This is 1 over cosine. This doesn't have a denominator, or the denominator is 1. If we're going to combine them, we really need to get a common denominator. So we're going to multiply by cosine over cosine, so this denominator matches this denominator. This will be 1 minus cosine squared theta over cosine theta. I just multiply these two together and put them together. 1 minus cosine theta, that's an identity. That's equal, 1 minus cosine squared theta. That's sine squared theta. Okay, well, if what we want is this, let's split up the sine theta. So sine squared theta becomes sine theta times sine theta over cosine theta. And sine theta over cosine theta is the same as tangent theta. We have proven it. Couple more. Backside, verify that it's an identity. We're going to go ahead and multiply everything in this set of parentheses by everything in that set of parentheses. Secant theta times 1, just secant theta. Secant theta times sine of theta. Minus tangent theta times 1 minus tangent theta times sine of theta. Now I'm going to rewrite everything in terms of sine and cosine. This is 1 over cosine. This is 1 over cosine times sine. So that's just sine over cosine. This is sine over cosine. And this is sine over cosine times sine. They've all got the same denominator, so I can add them together. I can join everything up. This is 1 plus sine theta minus sine theta. That's 0. So 1 minus, and then sine theta times sine theta is sine squared theta over cosine theta. 1 minus sine squared is cosine squared theta over cosine theta. And this is cosine times cosine over cosine. I can cancel one of these. With that, I get cosine theta. That's what we wanted. Okay, this one is just a little weird because neither of the sides looks very straightforward. But we're going to work it using this side. So the first thing we need to do is basically multiply it out. This is sine A minus cosine A times sine A minus cosine A. So we need to multiply it all out. Sine squared A minus sine A cosine A minus, so that was this one, now we got this one. And since order doesn't matter in multiplication, I'm going to put this in the same order as the other one. Minus sine A cosine A plus cosine squared A. Oops. Okay. Now, sine squared A plus cosine squared A, that equals 1. That's an identity. Just because they're in different parts of the expression doesn't matter. That can be replaced by 1. And then these two are like terms. So this is 2 times sine A times cosine A. 1 minus 2 sine A cosine A. We're very close, aren't we? Only this one's cotangent A. Well, okay, cotangent is cosine over sine. So if we multiply this by sine over sine, we're not changing anything. We're multiplying by something over itself. So that's just multiplying by 1 doesn't change the value, but it can change how we write it. So that's sine A, cosine A. Here we go. Let's shift the order. This is sine A times cosine A over sine A. Don't cancel, you'll be going backwards a step. And our goal is to get it to look like this. So 1 minus 2, that's sine squared A. That's cotangent A. And now this side matches that side, and we're done. Last thing. These are not identities. You are not proving these. These are equations and you're solving them. Well, you're getting them ready to be solved. Basically, there's no way that I can put this in the calculator or look it up on the unit circle. But if I can rewrite it so that it says something like cosine of x equals 0.6, I can just do arc cosine of 0.6 and get the angle. So I'm going to use the same techniques as before. In this case, if necessary, you can cross the equal sign because you're not proving they're equal. You are told they're equal and you're trying to simplify it. All right, cotangent is cosine over sine. Cosecant is 1 over sine. Dividing by a fraction is multiplying by the reciprocal. cosine of x equals 0.6. That is much simpler. We have one function on the left and a number on the right. That's what we want. Next step, we could just do arc cosine of 0.6. We're not doing that yet. We're just getting it there. Tangent equals 1/4 secant. Well, let's divide both sides by secant. Like I said, in this kind of situation, we can divide. All right, so on this side, that'll cancel out. Now here, this isn't much simpler, so let's try rewriting. Tangent is sine over cosine. Secant is 1 over cosine. Dividing by a fraction is multiplying by the reciprocal. Sorry, cosine of x over 1. That cancels. Okay, so what I've got now is sine x equals 1/4. Next one. All right. Well, what do I do with this? Okay, so I'm going to rewrite cotangent as cosine over sine. I'm going to want a common denominator, so I'm going to multiply that by sine over sine. So now I've got cosine x plus sine squared x over sine x. That doesn't look much better, does it? But okay. And this one, this is negative cosine squared x over sine x. I should say, I replaced cotangent x with cosine x over sine x. Cosine times cosine is cosine squared over sine. Okay? Now, we are going to add cosine squared of x over sine of x to both sides. Weird but true. Cosine x plus sine squared x plus cosine squared x all over sine x equals 0. Cosine of x, well, sorry, there's nothing we can do here, but this, sine squared plus cosine squared, that's 1. So now I've got cosine of x plus 1 over sine of x equals 0. This stumped me for a little while before I remembered I can go across the equal sign. So what I'm going to do, I don't want to have a variable in the denominator. I'm going to multiply both sides by sine x. This gives me cosine x plus 1 equals, well, 0 times sine x is still 0. It doesn't matter what x is. And finally, cosine of x is negative 1. I know that's a long one. Sometimes that happens. The next one's a really short one. I'm going to replace secant with 1 over cosine. That means this is sine over cosine, and sine over cosine is tangent. Tangent of x equals 1. We could then do arctangent of 1, and x could be 45 degrees or 135. No, sorry, 45 degrees or 225, or any multiple of 180 degrees plus that. But we get to that in the next section. For now, we're done.